is Prabhu. I'm a NASA NJSGC intern over the summer, and my project for over the summer was automating lattice creation for additive manufacturing, also known as 3D printing. And I'm a student within the Department of Mechanical and Aerospace Engineering at Rutgers University. My advisor for this project was Professor Hoan Lee, and my email is listed here in case you have any questions. So to begin with, 3D printing is a relatively new technology whose benefits can be extended to almost any industry, even aerospace. And in aerospace, there's a lot of benefits because aerospace manufacturing requires a lot of complex geometries, such as this part shown here, which is actually 3D printed. And in order to make these complex geometries, you have to use simple unit cells and then combine them for applications. The current problems with this is that designing the unit cells and combining them together in a modeling software such as SolidWorks or Siemens NX is a process that is time-consuming and memory-draining. Furthermore, there's no template yet for making these unit cells, so every time you make a new part, you have to create the unit cells again. So what I wanted to solve over the summer was developing a computer script that can produce unit cells based on what the user wants, with the inputs of size, shape, and thickness. So the objectives that I listed for this, that I wanted for this project, was that I wanted to use MATLAB to generate different types of unit cells for STL files, and the ones I wanted to focus on were simple cubic, face-centered cubic, and body-centered cubic, which are shown here below. Simple cubics are basically a cube, face-centered is a cube with diagonal struts, and body-centered with diagonal struts inside of the cube. And other potential unit cells I wanted to make were triangular and octahedral unit cells, which I didn't show here. So how I did this was I used MATLAB and SolidWorks, MATLAB to develop the code and SolidWorks to view the files. And how I did it was that I first found a code online that changes binary 3D matrices, also known as voxelized matrices, with ones which represent part of the object and zeros which are not a part of the objects. And this changes these 3 matrices into an STL file. I found this code online and I put it in the reference over here. So as you can see, this is 3D matrices with different pages for each array, and then this transforms into a cube. How I actually did this was over here. This is a 2D matrix with ones at the corner, and this turns into a cube. So my primary work this summer was developing algorithms that can produce 3D matrices in MATLAB. So how I did it, I'll show in another video, but the results are shown here. This is a simple cubic with a 5 by 5 by 5 by 5 simple cubic with a thickness of 2. Here's a face-centered cubic with dimensions of 49 by 49 by 49 and a thickness of 5. And here is a body-centered cubic with a size of 35 by 35 by 35 and a thickness of 3. And unfortunately, the trigonal and octahedral unit cells did not go well for reasons I'll explain later. And tessellating them, or combining a bunch of them together and making like actual complex geometries, I faced problems. So the conclusions, as you can see, I reached the objective of producing the cubic unit cells at various sizes and thicknesses. However, my shortcomings were that the triangular and octahedral unit cells failed because the code could not produce struts at angles, so the other unit cells looked askew. So this was my attempt at making a triangular unit cell, and as you can see, it looks very jagged and askew. And as for tessellating, I got it to work for smaller sizes, specifically beneath 5 or 6 iterations of tessellating, but once the tessellations got large, the files would be too large for MATLAB. So I'm pretty sure this is a 20 by 20 by 20 unit cell tessellated 4 times, or 3 times, my bad. And what I want to pursue in this with this project for later on is I want to make other unit cells, such as a triangular and octahedral, with using ANSYS APDL with a mesh to lattice script. And I also want to be able to fix my tessellate code so that I can successfully combine multiple unit cells, regardless of how big it is. And here are my references. that is all for this presentation. I will show a brief 1-minute video of my code at the end of this. Thank you. Hello, this is Prabhu, and here I'll show you how to use my code for the project that I was working on over the summer. So the main code is make cubic unit, and unfortunately I won't be able to show you the STL files that it creates, but I can show you the matrices that it creates. So this is the code, and it's pretty long, and basically how it works is first it creates the edges, and then depending on whether it's FCC, BCC, or simple cubic, it'll fill in wherever it needs to fill in with ones. So first I'll make simple cubic. So this is size of 11, thickness of 2, and 1 is for the simple cubic. And as you can see, as you expect, there's ones on the edges for a simple cubic. And next I'll make face center cubic. So this one has a size of 35, dimensions of 35, thickness of 3, and it's face center cubic. And it's pretty large, but if you can see here, there's ones to show the crossings of the FCC on the face. And lastly, here is the BCC, the size of 49, a thickness of 5, and 3 for the BCC. And here is the matrix. As you can't see the ones because the struts are inside of a BCC. And that is my code, and thank you for listening.